Trying once more. Alright, hopefully this should keep the text crisp. And keep the data rate down. This is something I should have done a while ago. I just haven't really prioritized it, so having having regular on stream, having an issue, I might as well try it. Alright. So this was all the meta Flesh 8 stuff that now has to be borrowed from the new code base. Flushes this new code. The old put dies. Did I make you end a bunch of torrents or something? Compute how many bits in the shape index take. Yeah, that's all fine. No, it's all boring. Rank 0. Do I actually use rank 0 underscore? I do. Here. But that can be a normal rank 0. Man, this is a lot of stuff here that needs to go back in time. Apparently I went one patch too far or something. I just lowered it to 30 FPS, so in theory, if I look at I don't remember the Twitch analytics thing. Twitch stream summary. I want to see my own settings. My channel. Do all this administrative stuff now before I get too buried in the actual content of the stream. All right. We seem to have a data rate that works. I'm going to go with it. Blob has lost its size as well. So as I mash together code from two different versions of this thing, there's no rank 1 or rank 1, rank 0 access. All right, that trimmed that down to pretty much the latest version of everything. So we've tweaked Blob to look like the one that we had in the completely unified version of things. Let's new build and see what works. Builder word 8. And then all the state changes. Oh, because I changed the name of it. I've already changed all the code to actually do the right thing. What are the semantics of the parentheses thing? Like how they get stored? They get stored as this two level index. Let me just get this bit, and then I'll. So they get stored as, like, there's one top level bit index that tells me whether or not something is a paren or something else. Like it's paren or an actual byte worth of data. And then for all the parens, there's another bit vector of just the parens with support for O1 navigation up and down the parenthesis tree. And on the right-hand side, we have all the data, or on the left-hand side, we have all the data. Oh man, we lost all the format updates too, though. Went one version too far back on gput. Add data void support using more fiddling with the API. So that's the version that I should have gone back to. I should have gone back to this one. Yeah, we had 3 completely separate arrays. And then associated with 2 of those arrays, there's all sorts of other little supplementary arrays. Each one of these things is going to get serialized out to disk when we get done. What was I looking for? I was looking for some of the put code. Just look at the appropriate version, right? Custom generics is fine. Then walk backwards in history. One parent. One parent. This is all the rank changes. Push meta gput. This is the version I want to look at. So once I get this gput thing fixed, let's take a look at the thing that, this is not my most stellar example of programming style, but whatever. So this drops the outer parens on the outer products and just leaves us with the put with parens call here, and then I just need put with parens. Skip string data constructors. Yeah, we all know this stuff by now. All right. Okay, so let's go back to this. I had a comment that showed the format roughly. So we have a sort of three different arrays. One is the bit vector of is it shape or data. One is the bit vector of shape, and I had, I believe, the polarity on this wrong. Like the opening parens are ones and the closing parens are zeros, whatever. And then we have the array that is just the raw bytes that we've been serializing. So that's what we scribble into with, this is what we scribble into with content, this is what we scribble into with shape. And this is what meta is. So for every bit in shape, meta is like defining the interleaving of these with these. So it's logically inlined, and so when we go to inspect meta, it shows them as if they were inlined, but they're stored separately. If that makes any sense. Type applications. Oh man, I went one version too far back. How it allows O1 navigation is all the succinct stuff that we talked about 6 streams ago. There's something called a range min max tree that can be stored in succinct space. So what happens is that set of parentheses takes as many bits to store as the parens just written out as a bit string plus little o of that length. And there's a navigation structure that's put on it. That's what all the combinators in Haskell Works data balance parens does for us. That's why I'm using all the Haskell Works libraries in the first place, is so that I have the rank and select structure on the top thing, and then the ability to jump directly to the closing paren for something, and to walk down to my child parens inside of the parenthesis structure. You could just pretend it's made out of pointers and stuff, and the intuitions aren't wrong. It's just a factor of 32 smaller. So in my haste to go back one version too far, I lost size. There we go. I'm being a very, very bad Git citizen. G size, all that stuff just should come back into existence, and then I'll look at Minip's patch for that. That made that a little bit cleaner. So yeah, so what I'll probably do is I'll do a quick review of the relevant bits of the Haskell Works APIs. Oh, no. I need a very specific version of generic SOP. Oh, I don't have the GitHub Teneb, because Teneb wrote the patch. Git submodule. Git submodule add. All right. Generic SOP. Oh, crud. Helps to not typo and put a slash in the middle of that. That was dumb. NIH generic SOP off of Teneb. All right. And then I need a Cabal project tweak. I don't know why that wound up in here. I know you don't have to write the Git. I just do it as a matter of style. Products 1. Put with friends. Oh, that's right. That changed the way that works. Content takes a builder now. Let's do that instead. And that way I can get rid of all the references to the... You now have an excuse for using hard tabs. What? Why does GHC bother to put out hard tabs? That seems like a terrible idea. Oh dear. Do I need serialize anymore? It'd be nice to be able to drop the serial dependency. Not that I really care too much, but this is builder dot. Builder to byte string. Builder byte string. Byte string takes a lazy, or there's lazy byte string that takes a lazy byte string. There we go. Builder lazy byte string. Take the lazy byte string in, and there we go. It does sound to me like that's a bit of a miss feature. Putable void. Have we caught back up to where we were? No. Put void absurd run put the state to result. It's just params now. I should start doing this in GHCID. Integer to W. What does M take? W should take, oh, it doesn't have the freaking size. Man, I really did go too far back. S times monoid is in data.semigroup. is followed by content. 123 is int 64. Sized. Could not deduce sized A from size. Puttable does not have size as a superclass in this version. Metas. Shape is paren. Put parens as parens. Access. Line 67 has an access. We're in blob. And those should be word 64s. That's right. Blob needs s times from data to that semigroup. Blob should have 4 arguments, but has been given 3. Shape bit count, this is old and needs to die. Content byte count also needs to die. Meta bit count dies. Line 56, trim 8. Oh, we're in get. Okay, so now we're in get, which I totally expect to be broken. Let's just get that to compile. Control blob. We can drop a bunch of things. We don't need to replicate M anymore. We don't need bits coding because that's gone. We don't need bytes put, that's gone. That's good. Balance parens, we don't need. Why? So just rename it to blob. Control monad is input. We've got no app and no replicate M. Never use strict monads or strict. Put LSB is no longer used. This is the thing that got replaced by all that push logic below. We don't need coding, and we don't need bytes put. So in theory, I should be able to rid us of the dependency on bits and bytes. And I think that's everything that we needed to drop dependency-wise. Hi, PPAF. What we're doing today is undoing a lot of the things that we did over the last couple of streams. So we're building this library for doing lazy binary serialization in Haskell, and we got too eager last time and realized that what we were doing was going to spin forever. I haven't really thought about your M&E categories recently. So, binary blob, get, put, orphan size. I think that's all good. Simple, nothing there needs to change. Do I need serial at all? I think we might be good without serial now. Sweet, we dropped a serial dependency. All by just saying, hey, let's just ask the builder to do the puts directly rather than lift puts for some reason. I don't know why I thought lifting puts was a good idea. I guess I thought originally that we might use some of the existing serialized instances for the leads or something. So we've got hardbound and HW rank select because we needed a bug fix from there. But other than that, everything else here is currently unrestricted. And we're using a branch of generics SOP. So these two things required fixes upstream. Cabal new build, Cabal new REPL. Data word and data void. So we've got everything. Run put 1, 2, 3 as word 8s. That's not run put, it's blob. I'm showing the wrong thing. Why would the solution from the last stream spin forever? So the main thing that we were finding was, I think Manip figured out that there were multiple potential fixed points for a thing, and there was no good reason for it to believe one over the other. Even though we would like certain behaviors, there's no good way for me to detect when I'm in a recursive case. And all the other hacks I could come up with, like use a partiality monad and then run it to some degree or something like that, we're all kind of awful to figure out how to explain to users whether or not you get parens or not. And I don't really want to build all the logic to do the same kind of hit map thing that we do in Lens for the binary, the biplate stuff. So the concern that I would have with manually tracking what types you've encountered would be polymorphic recursion and stuff like that. So one reason for going back to this split out thing where I have like the sized as a separate entity is that I could, in theory, like you can say, hey, for the size of this thing, for size of lists, it's variable, then just go infer the build process. So we could, in theory, just use that. That might be enough. What I meant was if we took the whole type and we were comparing exact types for equality, and I had list here and list of list and list and list. Yeah, I had types that didn't actually recurse exactly. I would like to be able to serialize and deserialize stream of unit. Come on, man. It should realize that it's of, a size exactly 0, so it doesn't have to do any work. Stop. Serializing was free. Deserializing. Realize that it doesn't, it can produce the result, and then lazily produce the result. It's by handling the edge cases correctly that we get all the other things to work. I'm only slightly tongue-in-cheek about that. And yes, it is. We're taking an infinite thing and collapsing it down to finite size. No. It's not halting. We know exact 0. We were able to we could deduce that from the fixed point, ideally. X equals 0 plus x, and then compute the minimum size of x. What do we have here? And get, wow, that was a really... That was when I typoed, or not typoed, when scrolling up through my command history caused me to edit the wrong position. What else we got? That can... Format.txt. Anything else here? It's just dead weight. Mess, old, succinct data structures, text. All that stuff is just me talking to myself. All right. Yeah. It's the least fixed point. Exactly. They're parts of the improved API. Now, minute, GitHub commit succinct binary. There was a PR from you. Show me the files changed. That's fine, that's fine, that's fine. That's the thing I want. Your version of gsize is probably much prettier than my version of gsize. We'll just put them side by side and compare. Size to something. Yeah, your K size uses HCMap correctly. You build NP, and you don't need to have my someone and all that stuff. I like it. I should just cherry pick. Like I said, I'm being a very bad Git citizen because I don't even know if things are in the same files right now. I guess this one would be. I think we've reverted far enough back that your patch would actually have applied. Commit minus and git. show up as an author-wise. Manip. Do I need to put a particular email address there for you? I don't remember. Actually, let me test that it works before I commit with your name in vain. Yeah, it's the get author email. It's a .pathc? I don't understand that. There we go. Manip it, manip. I was just going to do that. Ah. There. I've at least credited you with it appropriately, even if I didn't cherry pick it properly. So new build worked. Not run put blob. Oh, W no orphans. That should just let me start doing things like this for testing. doing here? Put int 8 doesn't work. Put dot. That's really tedious. All right. So the thing that I was trying to figure out after the stream last time was whether or not we could, because we have the separate size calculations, if we could just say, hey, look, get the size calculation right, and then the put and get will just follow. So like we had the manual list equals variable instance. And if I test this, sized A implies size list of A, sure. This is the one that I really want. Okay, so if we try and tie the knot on size the way we did before, we're going to get the same problem. So our size calculations here have the exact same problem as the tree thing that we were building before. So that doesn't handle recursive cases. So we have to, so Manip, your observation last time that I had overridden the size for list was completely spot on. On the other hand, in the presence of a correct size calculation, get and put should be able to be derived by magic, even with all the extra things that we wanted. So if we redefine success to allow for users having to write manual size annotations. So we need a constraint solver compute at least fixed point. And we would need to know whether or not it's infinite or not. Clearly we should write this as a custom GHC plugin. an otherwise bland and unusual functional language. Whose only innovative feature is this. Well, yeah, that's what I'm building. That's what this is all for. So the one manual instance. Everything else here works. Size, G size, all that's good. I'm kind of puttering at this point just to make sure that I've got things into a state that makes sense insofar as it can. All right, so at this point in time, we've basically managed to undo the damage we did over the last two streams. And now we're to the point where we need to start fiddling with getting. And we should also decide whether or not we want to have all of the distinguished constructor optimizations that we were building last time. Now that we know that it's the size calculation that was the culprit, if we just leave the size calculation as a user-supplied thing in recursive cases, I think we could have all the nice things that we were talking about last time. But I think what I'll do here is save this. Oops. There we go. And I'm honestly probably going to cut the stream short about now. I apologize for the fact that this has been a really, really short stream by my standards. Just my tailbone is really hurting from having fallen down those stairs the other day. So I don't really feel too comfortable sitting in this chair for a very long period of time. So I don't think anything is permanently damaged. It was just kind of a bumpy ride down a dozen stairs on my butt. So, all right, I'm going to call it there. Thank you, everybody, for hanging out, and hopefully next time we'll get around to doing the deserialization side and maybe come back and backport some of that distinguished constructor logic. I mean, for the most part, I'm fine. I got like a couple of scrapes here and there, but all right. Later on.